All right, everybody. Hello. My name is Thomas, and I do welcome to my channel. I do educational videos on many different subjects, and today I think we're on about the 25th episode of working with the reciprocal system of theory, system of theory developed by Dewey B. Larson back in the 20th century, from about 1930 until 1990 when he died, and then kind of revamped by Dr. Bruce Perrett, Dr. KVK Nehru, Dr. Gopi Krishna, and many others, at least several others, in the 21st century. And we've gone over kind of my biographical experience with the reciprocal system, Larson's biography, and then we went through his article or speech that he gave called The Deductive Development of the Reciprocal System. It gives you the step-by-step approach. Now we're looking at his final book, which was published posthumously in 1995, called Beyond Space and Time. We are kind of like in chapter 3. I do have a problem in that I've lost my copy of Beyond Space and Time, so I'm kind of going from my notes. Well, I didn't find a copy of the book, but I did find a better copy of my notes, or like slightly better notes. So we're going to work with that. We were working here now. The basic aspects of Larson's theory, again, is that the universe is, he was a mining engineer. He came up with many different, he was working on many different kind of chemistry problems in his off time from his job, and this was back in the 20s and 30s, and he eventually had a couple epiphanies and worked on them through an inductive process where he went from the specific to the general to kind of eventually figure out and arrive at his postulates. He's got two fundamental postulates, and since they're short, I can read them again. The physical universe is composed entirely of one component: motion, existing in 3 dimensions, in discrete units, and with 2 reciprocal aspects, space and time. Now that is his most important postulate. The second postulate is somewhat under dispute and not as important, just kind of just as a things that almost should be obvious, even though he got some things wrong with them. Second fundamental postulate: the physical universe conforms to the relations of ordinary commutative mathematics. Its magnitudes are absolute, and its geometry is Euclidean. Now, it does seem, that would make sense, but the geometry has been contested. The mathematics has been contested, and the magnitudes have been contested, mainly because these all apply, on Earth, but there are other realms where, like, for example, Euclidean geometry is just a subset of a larger geometry, like a projective geometry that is more encompassing. So Euclidean geometry is kind of just a particular manifestation of projective geometry. And so Dr. Bruce Perrett reformulated that second postulate. We'll eventually get into that. It's kind of getting into the weeds right now. So those are the basics of Larson's system. Now, I'm trying to find my good copy of notes here. Okay, now other people have come up with this idea that that the universe is made out of motion. Okay, but Larson kind of, including like Thomas Hobbes, and I believe Rene Descartes, maybe Arthur Eddington, And they you tried to go with this motion idea of the universe of motion, but didn't really get anywhere. And what I think enabled Larson to get further than they did is that he redefined space and time. Uh, and here he says, space has been regarded as a kind of setting in which the action of the universe takes place, a container for the material objects that participate in this action. And Larson really redefines space and time as not the space as not the container of the universe, but actually one of the contents of the universe. So the universe is made out of space and time, which go together in motion. All motions are a relationship between space and time, or it's reciprocal, a relationship between time and space. They're really, the same. It's just the numerator and the denominator of a fraction, or a relationship, or a ratio. So what Larson is saying is, here he says, filled with a substance having the properties of a connecting medium through which the various influences originating at one spatial location could be transmitted to distant locations. So he's saying investing space with the ability to act as a transmitting medium. So this is, what the 19th century scientists called the ether, a transmitting medium. There's got to be some kind of transmitting medium between, for action at a distance. Here he says, time has always been more elusive than space. Space is assigned the properties that were formerly attributed to the hypothetical ether. Okay, so he's really saying here that, the 19th century scientists used this idea of the ether as the transmitting mechanism. Einstein used the sleight of hand to kind of get rid of the concept, get rid of the word ether without really getting rid of the concept of ether. Okay, now here he's saying motion is defined as a relation between space and time, and it is measured as speed or velocity. Speed and velocity are the same thing, other than velocity is in a specific direction, whereas speed is a scalar magnitude having no or all directions. Space and time are the two reciprocal aspects of that motion. Space and time cannot have any significance anywhere that they do not have in motion. Okay, so more or less, space and time are illusory. They do not have any significance other than when they are together in motion. Space and time are simply the two reciprocal aspects of motion. They have no other significance. Similar in all respects. Time is similar in all respects to space, except that it is the reciprocal aspect. Space does not exist alone, nor does time exist alone. Neither exists except in association with the other as motion. And, there he goes with the box analogy. If you have a box, you have three things. You have the box itself, which is the boundary, which you could think of as like the speed of light. Again, remember in Einstein's theory, the speed of light is the maximum speed of universe. In Larson's theory, the speed of light is the neutral point, or the midpoint between two separate kind of sub-universes. So the speed of light is like the midpoint of the universe, and everything that moves slower than the speed of light is in space, everything moving faster than the speed of light is really in time. So you have the box, which represents the speed of light, and then you have the inside of the box, which is the space part, and the outside of the box, which is the time part. That's just like an analogy to be able to think about it. And then he goes into the abstraction that we talked about yesterday. Okay, he says that the general reciprocal relation between space and time, this is the only innovation that the new system of theory introduces into scientific thought. And then he goes through the postulate, and he goes to the second postulate. He says, no actual evidence to support the prevailing belief that time is one-dimensional. The time term in a space velocity equation is scalar, not because it is one-dimensional, but because it has no spatial dimensions at all. Whatever dimensions it may have are dimensions of time. As a condition of becoming a scientist, it is therefore necessary to assume that the universe is logical, orderly, and rational. And so this is the implied third postulate that we got to yesterday, incorporating the assumption that the universe is logical, orderly, and rational. And again, he says that, you really pretty much have to accept this as a condition of becoming a scientist. Now, I don't know, what he would think about chaos theory, or chaos science. But moving on, he just the conclusions derived from the basic postulate of the reciprocal system constitute a theoretical universe extending the development of a theoretical system whose validity we have already verified as a whole. We're able to explore not only the regions that are dimly visible, but also regions that are totally invisible. Okay, that was kind of what I was saying about time. If time is identical to space, other than they are reciprocals, but we only see space, we do not see time. So, but we can extrapolate. We can discover the qualities of space, and or what I would call the space time region. Like, so if you've got the box as the midpoint of the universe, then the outside of the box is I guess what Larson calls the space-time region, and the this side is the time-space region, the inside of the box. And there's a question of that terminology, whether he should have it the other way around or not. But that's how he has it. And we only are able to see this sector, the slower than light sector, but what we can glean from this sector, we can apply in the reciprocal to the other sector that we can't see, the realm of three-dimensional time. Here is the realm of three-dimensional space. We can make measurements and see our way there, but we can apply that directly and identically, except reciprocally, to the three-dimensional time region of three-dimensional time. So that is something that the theory allows us to see what he calls the dimly visible and the totally invisible. So this is again something that is a scientific breakthrough. Now, again, Larson, in his deductive development, he talks about how, where in his reciprocal system, 90% of legacy science, the previous, the current science, um, fits into his theory, where 90% of what the scientists have come up with, according to his deductive development, if this then that, if taking the postulates and going if this then that, if this then that, he incorporates 90% of science into his theory as being correct. It's the 10% that Larson is making the corrections on, and those 10% are generally in the realm of the very, very small, the very, very large, the very, very fast, and the very, very slow. So, in general, the Newtonian universe is incorporated in its whole in the reciprocal system. So you've got the Newtonian universe, and then Einstein comes along and he notices that, okay, the Newtonian universe is pretty much right, but it gets wrong answers here on the margins, when we're talking about speeds coming close to the speed of light, or when we're talking about, particles that are so small that they're microscopic, or where we're talking about, particles or bodies that are so big that we hardly can, resolve them, things the size of galaxies and so on, quasars. And even though quasars hadn't even been observed. And then, the very, very slow processes that take billions of years or whatever to accomplish. So that's where Larson is really starting. He has a book that's actually called Beyond Newton. Okay, so he's taking his theories beyond Newton. So he's kind of saying that it's a replacement for Einstein. Like, he's not even using Einstein as the basis for going forward at all. He confirms Einstein's equals mc squared, but and the quantum from maybe the post-Einsteinians. But in general, he's taking his basis as the Newtonian universe and moving forward. Or, as chapter 4 is called, reaching outward. And here he says, in the realms of the very large, the very small, and the very fast, and I would also say the very slow, the new concept of the nature of time leads to a drastic reconstruction of the relevant theory. The effect of this hitherto unrecognized motion in time that is responsible for the discrepancies. We do not perceive physical objects directly, that we have direct knowledge only of the sense data, and that our concepts of the physical objects are mental constructs based on that data. There is an external universe independent of man and independent of any observations that he may make. The physical universe is a universe of motion. That is, motion is the reality of which the universe is composed. Motions and combinations thereof are therefore real in any ordinary sense of the word. Some of the unobservables of modern physics, the nucleus of an atom, for example, are wholly non-existent. Some, such as electromagnetic or gravitational fields, are merely special ways of looking at physical situations, that is, describing the relations between motions, and belong in the same category in which we place such concepts as the center of gravity of an object or the poles of the earth. Atoms, so he's saying that the gravitational electromagnetic fields are merely conveniences for us to make measurements, and that things like the nucleus of an atom, according to him, is non-existent. The next thing that he's talking about here, sense data are merely messages conveying this information, not basic realities in their own right. There's another, okay, now this goes back to, going into this three-dimensional time region or sector. There is another half identical in all respects to the material sector. Okay, he eventually calls that the cosmic sector. Okay, so there's the material sector, then there's the boundary, and then there's the cosmic sector. And within the material sector, there is a smaller realm, and within the cosmic sector, there's also a smaller realm. So there ends up being kind of like five things: the boundary, the material sector, the cosmic sector, and then what he eventually calls the time region and the space region. And those are within these larger cosmic and material sectors. So there's another half identical in all respects to the material sector, except that space and time are interchanged. Inverse gravitation in the cosmic sector that moves aggregates of matter, of cosmic matter, toward each other in time. Okay, we're going to just leave it right there. I think I'll be able to negotiate this a little bit better now that I've got these notes here. But just keep with it. We'll figure it out, and we're going to work through this, and we're going to learn to understand the system. It's very powerful once we get the gist of it. Okay, so thanks, and we'll see you tomorrow.